Hello everyone and welcome to Elevate 2022. My name is Don Clayton. I'm one of the founders and the current president of Intertech Consulting. I'm here to discuss the approaches we've taken to solving Thorny.NET integration issues with PowerBuilder 2022. I'd like to mention that I am the author of this presentation and was not compensated by Appian for this opportunity. The presentation is protected by Appian Corporation under U.S. copyright law. All rights and references to third-party materials and products, including the DYMO printer products, are not owned nor expressly endorsed by Appian. In particular, DYMO printers are widely used in the PowerBuilder community. And Appian and Intertech are not warranting the suitability of the approach described here for your organization. But for more information on anything that you see here, please feel free to contact me after the presentation. Our agenda for today is to learn more about the approaches and limitations of consuming .NET Managed Code Assemblies in PowerBuilder. I'm going to talk about calling a .NET assembly from PowerBuilder and the enhancements that have been made in PowerBuilder 2022. One of those enhancements is being able to call back into PowerBuilder from that .NET assembly. I'm also going to talk about C# language and PowerBuilder language and feature mapping, and the process of creating an adapter or a wrapper for unsupported .NET features. I'm also going to talk about debugging and deploying this solution, and then I will share Intertech's approaches to integrating the DYMO Label SDK into PowerBuilder, thus illustrating the strengths and limitations of integrating PowerBuilder and .NET. My name is Don Clayton. I'm one of the founders and current president of Intertech Consulting, Appian's authorized North American consulting partner. I was fortunate enough to be in the beta program for PowerBuilder 1.0 starting in December 1990. After developing with PowerBuilder full-time between 1990 and late 1991, I began teaching PowerBuilder 2.0 and taught around 2,000 to 3,000 people how to use PowerBuilder. I've run projects that have had as many as 50 PowerBuilder programmers working on a project and ran PowerSoft's largest training partner in North America in the early 1990s. I founded Intertech Consulting with two friends I went to Rice University with, and we later became a PowerSoft consulting and education partner in 1995. In 1996, PowerSoft was acquired by Sybase, so we became a Sybase partner, and we remained so for 17 years before SAP acquired Sybase and we became an SAP partner. During the time Intertech was a Sybase partner, we were also a vendor to Sybase Professional Services and supported the Power Designer and EA Server products, as well as the various Sybase databases. Intertech provided consulting services through Sybase Professional Services to about 200 different companies. Also, Intertech started using the Appian for PowerBuilder product around 2003. And over the course of about 12 years, we helped numerous companies become successful with the Appian for PowerBuilder web enablement technology. When Appian acquired PowerBuilder from SAP, Intertech was fortunate enough to be invited to be Appian's authorized North American consulting partner. Intertech provides a variety of professional services focused on the PowerBuilder solutions, including consulting, education, programming, and project management. For more information about our services, please contact me or visit our website at www.intertech.us. I'd like to give you a little context and background for this presentation. Intertech recently developed a solution for a client using the DYMO.NET Label Printer API, which was expressly built for DYMO's next generation printers. DYMO has deprecated its legacy COM solution and now offers a .NET Framework API called the DYMO Label SDK, which is rich in functionality but relatively difficult to consume in PowerBuilder. Thus, I will share Intertech's approach to integrating the DYMO Label SDK into PowerBuilder, illustrating our approach with an emphasis on the capabilities and limitations of integrating .NET to PowerBuilder. DYMO Corporation has moved aggressively into .NET and has abandoned its COM controls for managing their printers in the process. Instead, there's a series of DYMO.NET SDK resources shown here, including a support forum for the SDK, GitHub where you can find solutions and samples and projects that will work for you, and then also the DYMO Connect framework itself can be found on GitHub. the DYMO framework depends upon a large number of other framework elements that can be found in NuGet, most importantly the Skia Sharp subcomponents. While there, you can find some good .NET examples, including this WPF example I'm going to demonstrate, which exercises all the major methods that you might need, including getting a list of DYMO printers, selecting a printer, opening a label file, setting a field in a label, finding out if there are any errors, and then finally printing the label out. This is the DYMO Connect SDK sample that comes with the SDK. When you run it, and I'm running it here inside of Visual Studio 2019, I can browse for a label file. I'll go ahead and open up the label file here, and as you can see, I can update the label, I can type in a value, I can select the object, update the label again, update the preview, I can select a printer, I can specify the printer role if it's a twin turbo printer, and so forth. So this is about 80% of what most people need to do with DYMO printers. I'm going to show you the standard DYMO API. As shown, the DYMO API has a lot of functionality, but has a lot of unsupported PowerBuilder language constructs. Things that are common in C#, like interfaces, which are contracts to support the behavior of classes. There are innumerable types in .NET that don't have analogous types in PowerBuilder. .NET objects can be passed around by reference fluently in C#, but not all .NET classes can be passed out to PowerBuilder. And there are other unsupported language constructs. So in order to consume this API effectively, we had to develop a bridge class that allows for PowerBuilder-friendly invocations of the needed methods. For PowerBuilder to be able to consume .NET classes, there is a framework to allow PowerBuilder to call into .NET and vice versa. There are two classes in PowerBuilder that control all communication to and from .NET. They are the .NET object and the .NET assembly. The .NET object can be found in the PowerBuilder browser under the System tab. As you see, it has a constructor and a destructor event and a series of functions available to it that correspond closely to the Power object from which it is inherited. Likewise, the .NET assembly class in PowerBuilder is the gateway into the .NET assembly world and has a set of events including constructors and destructors, as well as a series of functions to facilitate working with .NET. So the .NET object is going to invoke the .NET assembly, and then the .NET assembly has the ability to call back into the PowerBuilder environment if necessary. There are some enhancements to calling .NET assemblies that were introduced in PowerBuilder 2022. Key among these is the ability to support invoking PowerScript events from within the C# code. And in order to do that, two new methods have been added to the PowerBuilder .NET object class. The register object method will register the PowerBuilder object with the C# Managed Code Assembly. And then after registration, events in the PowerBuilder object can be triggered by the .NET assembly. Unregister object will unregister the previously registered PowerBuilder object. The PowerBuilder .NET assembly class has some new methods as well. There is a load with .NET method, which allows you to load a .NET assembly version 5 or later. You can then call the PowerBuilder code from the .NET assembly, but the ability to load and execute different .NET assembly targets and dynamic libraries is dependent upon some DLLs that are available from Appian Corporation that must be present for your C# application or the C# Managed Code Assembly to be able to call back into the PowerBuilder environment. Those are the pb.NET Framework Invoker DLL for the .NET Framework, the pb.NET Core Invoker for .NET Core, and the pb.NET Invoker DLL for vanilla.NET. Once the PowerBuilder instance is properly registered with the .NET assembly, it's possible to manage a callback into the PowerBuilder environment, into the registered object by calling in the PowerBuilder namespace registered object.trigger event. This must be called from your C# code in order to trigger the event in the registered PowerBuilder object. There's details on this in the application techniques guide. It is possible to call pretty much any event in PowerScript from C#, but there's a couple of limitations for that. One is that you may have to use the more weakly typed forms of the trigger event method, and then also the user event can only have one string type parameter or no parameter at all, with one string type return value or no return value at all. So as long as the events are fairly simple events, they can be triggered from within the .NET Managed Code Assembly. In terms of developing these .NET assemblies, they can be developed in .NET Framework, .NET Core, or .NET Standard. .NET Standards version 1.3 to 2.1, .NET Core version 1.0 to 6x, and .NET Framework 4 to 4.8, with .NET Framework 5.0 right around the corner. If the assembly DLL that you're going to call into was created by PowerBuilder.net, and I'm talking about the old PowerBuilder.net, then the dependent Sybase DLLs must be copied into the same folder as the assembly DLL. So there are some Sybase era DLLs that are archived under the Appian PowerBuilder installation folder for the binaries to be able to call back into old legacy PowerBuilder.net managed code DLLs. It's important to have a strong working knowledge of data types in both C# and PowerBuilder and the mapping between those two in order to effectively work in this environment. Virtually all PowerBuilder standard data types can map to .NET data types, but there are many .NET data types that do not map very well to PowerBuilder. So PowerBuilder and .NET data type implementations can be different even if the name is the same, the name of the data type is the same or very similar. And there's some data type mappings that are not obvious. The PowerBuilder char map to a .NET string. The PowerBuilder ref char maps to the .NET char. PowerBuilder blob arrays map to the .NET byte array arrays. And the index in PowerScript arrays always starts from 1, while indexes in .NET start from 0. Therefore, PowerBuilder arrays in position 1 map to .NET arrays in position 0. For more information on this, there's a very helpful PowerBuilder help topic on C# language versus PowerScript language constructs, and you can see the mappings between the data types and the support for those data types here. Also, you can see the supported return data types as well. In terms of .NET classes are supported, but certain C# language constructs are not. Again, an interface, which is a contractual obligation for a class, is not supported. So you can't pass an interface to and from PowerBuilder. Structs are not legal to pass back and forth. Abstract classes, generics, internal classes, partial classes, protected classes, private classes, and static classes, none of those are supported. But if a class has a nested class, nested classes are in fact supported. But rather, instead of using the dot notation, use the plus sign to access the nested class. For example, namespace.class plus sign nested class. When using .NET methods, there are additional unsupported methods and structures to be aware of. Date and time classes on the C# side can only be used as arguments and cannot be returned. The C# enumerated data type is supported through the PowerBuilder long data type. Using structs or generics as parameters in the callback function are not supported, but you can pass a transaction object reference into the C# class to invoke logic in the PowerBuilder transaction object after registering the PowerBuilder instance with the C# instance. Transaction object arrays are not supported, however. Inside of .NET, the returned instance will have been auto-instantiated as a .NET object by the PowerBuilder language. You can manually destroy this auto-instantiated object when it is no longer needed. Some additional things to be aware of regarding unsupported .NET properties: indexers, SByte type properties, transaction object arrays, structs, two-dimensional PowerBuilder blob arrays, and C# enumerated data types are not supported. There are also data fields that are not supported. Additional unsupported .NET properties include indexers, SByte type properties, arrays of transaction objects as mentioned before, structs, two-dimensional PowerBuilder blobs, and certain data fields are unsupported. However, you can pass transaction objects which are only supported in .NET Framework, not in .NET Standard or .NET Core. Transaction objects, when represented in .NET, will not support the Oracle Managed Data Provider for .NET. These limitations can be worked around. It's commonly necessary to create an adapter class, or what can be known as a wrapper, that would call into the desired .NET assembly. The adapter class can then be a connector or a bridge between the .NET assembly that you write and the PowerScript environment. The PowerScript classes will then wrap the adapter class. These can be written by hand, but it's much easier to use the .NET importer to generate the necessary wrapper code. So in PowerBuilder, I can create a new standard class, and then I can pick my .NET object, and I now have the beginnings of my .NET object. It's much easier to use the .NET importer than to write these adapter classes by hand. When creating .NET adapters, the goal of the design would be to create an adapter that manages its way around the unsupported features between the two languages. You can replace C# lists with string type arguments. More complex data types can be broken down into generic data types. You can replace complex data types with simple data types. You can look at decomposing a more complicated call into smaller calls that will take advantage of supported features. But you have to determine the unsupported features in the target .NET assembly by loading it in the .NET DLL importer. The .NET DLL importer will then show you the unsupported features after you click on the View Failed Items button at the bottom of the tool. So when developing your .NET assembly, you only need to import the adapter using the .NET DLL importer. You can then deploy the remaining reference DLLs, that is the DLLs that are referenced by your adapter, into your PowerBuilder target. I'm going to demonstrate this, but when using the .NET importer, you would select Tools from the new dialog and select DLL Importer menu, and then you have to select the DLL, the framework type, the destination target, the destination library, and some advanced settings. Once you've selected the DLL, what's exposed in the DLL will be presented to you in a PowerBuilder dialog, and you'll be able to select the classes and functions that you want to import. Once again, I'm going to demonstrate. So I'm back in PowerBuilder. I'm going to click on the new dialog. I'm going to come to the Tool tab. I'm going to highlight and select the .NET DLL importer, and I get the .NET DLL importer dialog. At that point, I have to select my .NET DLL, and first I'm going to select a DLL which is from the DYMO framework that has all the common methods in it, but is not particularly going to be well supported by PowerBuilder. When I select that, what you'll see is that while it is able to open up the DLL and introspect the DLL and find out everything that's in it, there's a large number of failed items. And a lot of these things are things you'll want to do, like being able to find your printers, or find out if the printer status has changed, or printing a range, or any number of other sorts of things like that. So there's a lot of things that are not supported in the DYMO Common DLL. You can also click on the Advanced Settings button to specify some more detailed settings for the import. If I expand the Advanced Settings area on the .NET DLL Importer dialog, you can see that I can provide generic prefixes for object names. I can add generic prefixes for function names, generic prefixes for accessor and mutator functions in C#, and identifying prefix arguments, other sorts of things like that, appending numbers to duplicated object names, encapsulating a .NET assembly object in each .NET object, and also incorporating try-catch error handling in the .NET object, which I always check that. So as mentioned, each mutable property, which means it's a property that can be changed, will have two functions imported by default, a setter and a getter. Read-only or write-only properties will only have the setter or getter as warranted. And then you can also get or set an instance's properties. There are some other limitations here. You cannot use nested dot notation more than one level deep for getting or setting a property. So you may have to write a method, for example, which calls more deeply into a managed code assembly. For example, printer.information.name equals DYMO would be unsupported. And as mentioned before, arrays of generic types, delegates, interfaces, or classes, including abstract classes and interfaces, are not supported. And private or protected properties are not supported. You couldn't do that in PowerBuilder either, for that matter. When you are using the .NET DLL importer, and there are aspects of the DLL you're using that have unsupported features, you will be presented with a View Failed Item option at the bottom of the dialog. When you click on that, you'll see a list of the items that have failed, which means you will not be able to call or get anything back from these particular things. So a good design, if you've designed your adapter properly, when it comes time to import your adapter, you will not have any failed items. I'm going to demonstrate that now with the adapter that we wrote for PowerBuilder. So I'm back in PowerBuilder now, and I'm going to go ahead and click on the new dialog again, and I'm going to click on the .NET DLL importer. And instead of picking the DYMO Common DLL, which is the DLL I picked before, I'm going to click on our DLL, the DYMO SDK for PBDLL. When I open, and that in the dialog, I can select everything. And again, notice that there's no failed items here. And so in that case, you can tell that there are no unsupported features in the wrapper DLL that you have developed. Again, by clicking on the Advanced Settings chevron, you can specify your getter, setter prefixes, and so forth. And again, always try to incorporate your try-catch error handling in the .NET object class. So then you would go ahead and click on Import. Once my non-visual has been successfully generated in my target library, I can open up the source. And as you can see, the source is really just PowerBuilder code. We have a non-visual object, NVO DYMO, that's inherited from the .NET object as described previously. I've got an assembly path, which is our assembly. I've got a class name for the objects that are going to be called inside of that assembly. And then there's a lot of code that's been generated for me by the wizard. There's some constants for success or failure. There are some private methods and attributes for handling errors. You can see that all of the methods that I have exposed through the C# DLL that we developed are now either functions or subroutines, and then the wrappers for those individual methods are here, And you can see that you've got a little error handling up front. Then you've got some error handling state retention information. And then you can see the other things in the method. On the other hand, if I open up the class, the non-visual that is, in the painter, then I can see the methods that were visible. And a good example of that would be the get printers method. This get printers method is exactly analogous to the get printers method that returned the list of DYMO printers in the WPF example I showed you earlier. So you can see that it is in fact going to instantiate the class and then go ahead and trigger the method itself. As your .NET assembly target matures, you're going to want to debug it. Let's talk a little bit about debugging your .NET object. It is possible to debug interactively directly from PowerBuilder. There are a few caveats. One of them is that when you're doing your C# assembly, whether you're working in Visual Studio or you're working in Snap Develop, it's important that the build from the project inside the solution, inside of Visual Studio or inside of Snap Develop, be located with the PowerBuilder library that contains the NVO. If you do that, then you can build your .NET solution. The .NET solution will be built into the same folder that your PowerBuilder library is in, and thus when you step into the PowerBuilder code and thus trigger your .NET solution in debug mode, you can step into the debugger on the Snap Develop or Visual Studio side. Once your application works in development, you're going to want to deploy your target. And so in deploying the solution or the target on the, to use PowerBuilder terms, you'll have to, in addition to deploying your PowerBuilder application in runtime, you have to deploy the following. You're going to have to deploy your .NET Adapter Managed Code DLL and everything it depends on. That means in our case, our DYMO DLL with all of its dependencies on the DYMO SDK, all that stuff has to be deployed. Also, the underlying .NET Managed Code DLLs that are called from those DLLs, and then any other dependencies that are stipulated in those .NET projects. Likewise, if you want to make callbacks into the PowerBuilder environment, as we've discussed it earlier, then you have to include a DLL that is going to accomplish the callback for you. That would be the pb.NET Framework Invoker for the .NET Framework, the pb.NET Core Invoker for .NET Core, or the pb.NET Invoker for vanilla.NET. And again, if you have legacy Sybase .NET Assembly DLLs that were built in, let's say, Sybase PowerBuilder .NET 12.6, then you would need to call the, you need to have the PowerBuilder .NET assembly wrappers for that, and I talked about where those were located earlier. So there's just a few moving parts to be sure. I have a few final thoughts about PowerBuilder and C#. PowerBuilder is a much more forgiving language than C# language, but the .NET Importer Wizard is super helpful. Aligning the development environment for rapid debugging, as I just mentioned, is key. You want to be able to step into your C# project in debug mode from PowerBuilder, and there's just a few tricks for doing that. Also, deployments can be problematic due to the myriad dependencies created, and so we think it's best to treat your PowerBuilder deployment as a what we call self-contained deployment and not depend on anything in the .NET Framework Global Assembly Cache or GAC or any classes being registered in the .NET Framework in order to work. So be careful and pick your battles, but it's a winnable battle. At this time, we're going to have some Q&A. Are there any questions? Well, those were great questions. Be sure and connect with the Appian community at community.appian.com, where you can find discussions, tech articles, videos, online training, and more. Also, in the fullness of time, this video will be on YouTube. You can find Appian PB on Facebook, LinkedIn, Twitter, and YouTube as well. Finally, once again, thank you for the opportunity to present this topic to you. I hope you found it to be informative and clear. If you have any questions at all, feel free to reach out to me at dclayton@intertech.us or find me on LinkedIn. Thank you very much and have a nice day.
you.